Okay. Hello, everyone.
Hello, guys.
Hey, welcome to another edition of the Astar Tech Talk. We'll talk today about something that Astar team is very excited about, and Pierre from Astar team will be doing the talking and explaining. I'll be monitoring your questions and answering, hopefully, as well as Pierre. So, Pierre, please take over.
Hey, guys. I'm Pierre, REST developer, WASM smart contract developer at Astar. And yeah, today Mario and me will present to you XVM walkthrough. So I will explain what is XVM and especially how to use it from WASM smart contract using our Inc SDK. So let's go. So today's agenda, we'll just introduce what is Astar. We will see what is cross virtual machine, how to use it from WASM, then a code walkthrough of our SDK and a live demo. And of course, take any question as you have. So Astar Network is the future of smart contract for multi-chain. Today we'll see XVM, but we'll also have XCM. So our smart contract will be really ready for a multi-chain future. We, of course, in first support WASM smart contract that we will show today. We also have dApp staking, so people can stake on dApp, and this dApp can have a basic income. So it's really good for builders. And then, of course, XVM, that is our most unique feature, cross virtual machine, and we'll talk about it today. What are Astar Tech Talk? So what you are actually watching now? So it's a format intending to target developer and also it's from developer of Astar. We deep dive on technical topic. You can ask as many questions as you want. And the whole goal of this is that you guys, you builders, you know what is the latest feature on Astar and how to integrate it to your dApp, to your innovative project to build more powerful dApp on Astar. And XVM, I think, will be a great candidate for it. So what is XVM? In a nutshell, it's a way to call a smart contract from one virtual machine to any other. What is its architecture? It's just an interface, and basically it's a substrate palette, and each virtual machine, so WASM and EVM, has its own adapter, so XVM adapter, so it can be callable from any other virtual machine. What can you do with XVM? So from WASM smart contract, user can call and query EVM contract with their Polkadot native address. From an EVM smart contract, user can call and query WASM smart contract with their EVM native address. One practical example is imagine Alice holds 100 units of any ERC20 on EVM. And in WASM, with the WASM smart contract, Alice call PSP22 controller contract to transfer 100 units to Bob. And then the final state is Alice holds no unit of ERC20, and then Bob holds 100 units of ERC20. And this happened without calling EVM directly. This happened only by calling WASM. So this is the full implementation diagram. So I hope you can see my mouse. So basically, only the red dApps are the smart contract deployed by teams, and everything else is just part of Astar runtime. So there is no configuration. It's just like the architecture diagram, but everything you see is already implemented and ready to be used. So the example I just described before, so making a call from WASM. So here you have your dApps, okay, your WASM smart contract that will use EVM SDK. So in this case, PSP22 controller. That will go through chain extension. That is a way for WASM smart contract to call palettes. It will go to XVM palette, then to XVM EVM adapter, because we are calling EVM, and then we'll finally reach ERC20 deployed on EVM. So the other way around from EVM. So a contract use Solidity XVM SDK that will, of course, use a precompiled contract. That is the way for EVM smart contract to call palette extrinsic. We'll call XVM, and we'll call XVM WASM adapter that will reach finally the WASM smart contract. There is also an error here. There is XVM API. So we can say that Contracts API, XVM API, and EVM API are right now a universal API. And we can imagine in the future that XVM is really the API of Astar Parachain, and that all XCM call can enter via XVM and then be dispatched to the VM that you target. Also with this architecture, it will be really easy to add a new virtual machine in the future and add it to XVM and then be callable from any other virtual machine. I don't know if there is a question on this. There is no, okay.
No, so far no questions.
Let's continue. So how to call an EVM contracts from a WASM contract? So let's deep dive on how to do it. So chain expansion exposes one call, which is XVM call. It takes 3 arguments. So first argument is VM ID. It's just a constant of which EVM identifier you want to call. So it will be EVM ID. In this case, the target is the address of the target contract. And of course, it should be in the, let's say, it should be in the format of the targeting virtual machine. So in our case, it should be a 20 bytes address because we are calling a contract on EVM. The input should be encoded as it's needed for its virtual machine. So here, as we are calling EVM, it should be encoded in the EVM ABI format. So what that is described on Ethereum. So if you are familiar with Solidity, it's ABI encode with selector, then the function selector, which is the first 4 bytes of the function name, and all the params. This is the most tricky part. And of course, we understood it. So that's why we created an SDK with the most used contract. And also for all your more innovative case, we are working on a transpiler that will automatically generate from an EVM ABI, so a JSON. It will automatically generate an Inc smart contract code. So you can basically interface any EVM contract directly to an Inc smart contract using our tool. It will be disclosed in some weeks, but it's already working. So we are already excited to show you this. But the XVM SDK, XVM SDK is already available, and that's what I will present to you today. So what is it? First thing, it implements XVM chain extension. As you know, chain extension has two implementations. One implementation is a runtime and one implementation in Inc. So you should use this implementation in order to call chain extension in your contract. It has 6 contracts. The first one are ERC20 and ERC721. The particularity of those contracts is that they don't respect PSP interface. And also in their argument, you use EVM address, so 20 bytes address. So it will be really easy to migrate your assets from one VM to another. Then we have a PSP22 and PSP34 controller. So PSP22, it's the ERC20 equivalent, and PSP34, it's ERC721 NFT equivalent. And those contracts respect the PSP standard, but they don't hold any storage. They don't hold the users' balances. They basically just control the underlying token. And I will demo it just after. And then we have PSP22 and PSP34 wrapper. It's like any other wrapper. It has a deposit and withdraw function, redeem. So basically, you deposit an underlying token to the contract, and then the contract will mint it the same amount in a 1-to-1 ratio. And of course, you can withdraw or redeem, burning your token, and then getting back the underlying token. The XVM roadmap. So where we are now. Now we shipped XVM v2 in Shibuya and Astar Local. So you can already use it in our testnet, and everything that I will present from XVM SDK is already working on Shibuya. But this version will never go to our live environment, Shiden and Astar. We need to wait for XVM v3 that we are actively developing. It will have better error handling, and also right now, XVM call cannot return values. So that means you can only do transactions that will modify the state, like approve, transfer, transfer from, but you cannot query values like balance of or owner of. And this will come with XVM v3, and then this version will be shipped in Shiden and then Astar. So let's have a look at the XVM SDK. If there is question, I can take some.
Yes, there are a couple of questions. Maybe you'll be talking about this, but let's see.
Okay.
I will answer now. So is XVM possible to interact with EVM contract on other chains like Moonbeam?
So XVM, it's a way to call VM within the same parachain, and to call other VM from other parachain, it's in the scope of XCM. So basically, the answer is not yes or no. It's just that XVM does not intend to do. It's not implemented to do cross parachain communication. This is XCM.
Yeah, I think Dean already replied to the same. So thanks. And one more. Does SDK support ERC 1155 and 5114 soulbound format?
Right now, there is no implementation for those, but happy to have it. I think when I will show implementation of ERCs and PSP22, I think it will be really easy to implement other standards.
Okay, thanks. We have one more, but I will leave this later because Ali will be talking about. It's about how many signings are needed for the XVM call. And also, just to note, I posted a poll. Let's see, guys, if you know how the format of addresses look like. So Pierre will also be talking about this. So it's good that you pay attention. So far, it's a wrong answer.
So guys, I posted in the chat the repo for the SDK. Let's have a look at it. So in the README, I describe the different implementation that there is, and also I describe the step to trade locally. This is what I will show after, but I think if you want to trade locally or even in Shibuya, please check those steps. So we have two folders. First folder is a library. So here we just implemented a chat extension and created a helper. I will not go through it. If you want to check, I will let you check. So we have 6 contracts. I will go through ERC20 and the PSP22 because it's kind of the same in the NFT standard. First one, ERC20. So it's an Inc. smart contract.
Can you please increase a bit? Cool, thanks.
So it's an Inc. smart contract. And here we implemented custom environment for XVM chain extension. This contract constructor takes the EVM address of the underlying ERC20 and expose approve, transfer, and transfer from. So how does it work? You have a transfer function. It takes 2 arguments, which is the 20 bytes array of the EVM address. So for example, if Alice wants to transfer token using this contract to an EVM address, this is perfectly suited because here you can input the EVM address. And then first thing, it should encode
sorry, maybe at this point, just to educate our audience. So the address formats, can you say the difference between EVM and WASM?
Okay. So here in the README, you can see a nice tool by Hun. So you have your address in Polkadot, which is 32 bytes address. Okay. And then you have the EVM address, which is 20 bytes address. And we will see later how to cast Polkadot 32 address to EVM address. But basically, address in substrate is 32 bytes and address in EVM is 20 bytes. And you can, of course, from a 32 bytes address in Polkadot, you can have address in EVM. You can get the address. Is it clear?
Yeah, thanks.
So how to encode input? Here we use transfer encode. So let's have a look at it. So first, transfer encode, we can see it takes H160. So this is the type of 20 bytes address from EVM, but it's basically just 20 bytes array. So that's why we can cast it directly with into. And then value in ink substrate balances are also in Rust. It's U128. We don't have a primitive type U256. So that's why we cast it to a U256. And it's, of course, safe because max value will never panic. And what do? We have our transfer selector. So it's the first 4 bytes of transfer. So here, where is it? Here. So it's the first 4 bytes of this hashed in KESAC 256. And then we encode the argument. So we have to and value. And then we use ETH ABI to encode the transfer and extend it with the args. And now we are ready to call XVM. So here we call XVM, so via chain extension. 3 arguments. First argument, the ID of the virtual machine we want to call. So here it's EVM ID. Okay. And then the address of the contract we want to call. And here we remember pass it to the contractor. So we are taking it from the contract storage and the encoded input. That's all. Then this will call XVM and we'll check if it's okay or not. Let's have a look right now at PSP22 controller. So what is new in this contract? At first sight, it's the same one. It implements custom arrangement of chain extension. Selector is the same, of course. Constructor is the same.
Maybe this is good point. If you can repeat what's chain extension and what's precompile.
Okay. So in an environment, for example, palette contracts, where there is a lot of WASM smart contracts, smart contract can call each other, but there is no way for a smart contract to actually call other palettes because this unsafe environment is closed. So in order for smart contract to call palettes extrinsic, you need to add chain extension that will add new method to the palette contracts API. And then your WASM smart contract will be able, via this chain extension, to call palette extrinsic. So we will have, for example, dApp staking chain extension. So your contract can call dApp staking palette. Palette assets chain extension. So your contract can directly call palette assets. And here XVM, and XVM, of course, and XVM, which is a palette. And then we add chain extension. So the contract can call XVM palette. It's actually the same as precompile. So in precompile, this is the same. You have precompile contract at the address that you can call to communicate from contract to palette. So what's the difference between this contract, so PSP22 controller, and ERC20 that we saw previously, is that this one implements PSP22 interface. So here, function name, argument, and return type are based on PSP20, and of course, custom selector. How encoded is made here? One difference is let's have a look at transfer. the 2 is not a 20 bytes address. It's an account ID. But EVM does not use 32 bytes account ID. So first, you need to cast this 32 bytes account ID to a 20 bytes array, so H160. And let's look how it's done. It's really trivial. It just takes the account ID and then takes the 21st bytes. And then that's the same. Transfer encode, it's exactly the same implementation. And you call EVM as described before.
Okay, so Pierre, now at this point we are losing basically those extra bytes, right?
Yes, of course. It's truncated. Yeah, something I wanted to say is like right now, as you can see, this PSP22 controller, it has approve, transfer, and transfer from as inc message that come from PSP22. But there is two function missing, which is approval, not approve, and balance off. So this is query. So to query the approved amount and to query the balance of an account. And those one are missing because in the implementation in XVM v2, you cannot query function. So this PSP22 right now, it's not really usable because it does not fully implement the standard. But there is a solution for this. It's PSP22 wrapper. This one implements full PSP22 standard from OpenBrush. And basically, how does it work? You have two functions, deposit and withdraw. So Alice call deposit, and first Alice will transfer its ERC20 token to the contract, and then this contract will mint on a 1-to-1 ratio token to Alice. And if Alice wants to redeem its ERC20 token, first she burns her PSP22 tokens, and then the contract will actually transfer back its ERC20 token to Alice. So this implementation fully implements PSP22, so it's already usable on any DEXs. I don't know if there is other question for the implementation. If not, let's go to the demo.
Continue, please.
Okay. So let's have a live demo of the example I described before. So first, I will use Remix to deploy an ERC20. And then I will transfer to Alice 100 units of this ERC20. Then I will deploy on WASM a PSP22 controller. And from WASM, I will transfer 100 units to Bob. And then I will check that in the ERC20 in EVM, that Alice finally holds no unit and that Bob holds 100 units. So for this example, I'm using Astar Collector version 4.38. The thing is, last version of our node is introducing Wade v2 and Polkadot.js UI. So the UI that we use to interact with a contract. Unfortunately, it's not updated yet. It will be in some days, I hope. So that's why right now I will be using the previous version. But of course, if you're using from a dApp with your own JavaScript code, it will work perfectly. Running the node, and for thing, deploy ERC20. So here I'm in Remix. Okay, here I have a basic implementation of ERC20 that will mint a lot of token on deployment. I will deploy this, of course, you compile it, and then to deploy it, I will use this account, which is the dev account that is funded. To find and add this dev account to your MetaMask, I advise you to go here in the README of XVM SDK and follow this add test account. It will give you a link and how to add it. Then usually when it's MetaMask local, when you run and again new node and you do testing, if you're on local, you also advise you to go to advanced and reset your account so you're sure that your transaction are getting through. Here usually it's Remix VM London, so you should choose injected provider and then deploy the contract. Then confirm the transaction. And here you have the contract. Okay. But right now, Alice does not have any token because those tokens were minted to the deployer, which is my dev account. So first, I will go to Polkadot.js, my accounts here. I will copy Polkadot account of Alice, and then I will get its EVM address. So I input my address here, copy its EVM address, go to Remix, and transfer 100 token from Alice, from my dev account to Alice. So let's the transaction, confirm, and then we can check that Alice holds 100 now. Okay, we're ready to go. Now let's deploy the PSP22 controller. So I go to developer, contract. So here it's not on chain because I made it before. So I will just delete it. Okay, so right now it is clean. I click upload and deploy code. Then I go find my .contract file in my folder. Okay, so usually under target, inc, and here PSP22 controller, my .contract file. And then in the constructor, I should input the EVM address. So I go to Remix and copy the EVM address. And then deploy. Now it's deployed. So I will transfer from Alice. So Alice right now hold 100 token, and I will transfer it to Bob. Before, so you see that I don't cheat. I will check balance of Bob on EVM. Okay, so this is address of Bob in EVM. And Bob has right now 0. Go back to the contract and then transfer call from Alice to Bob. Here it's a balance of Polkadot.js UI will use a chain decimal, and so 1 here will be 1 with all the 0 of chain decimal, but as here I'm not using chain decimal, 100 is 100, so you should use like the most smaller unit, and then I will transfer 100. Estimated gas is broken, I don't know why, so here just it's a Polkadot.js UI issue. And then if I do a dry run, I can see that it's okay. So I can execute the transaction. You can see that it's working. If I go check the event, I have 3 events. 1 event from EVM coming from the contract. So 731, you can see that 731 is the address of the contract. XVM call send OK, and contracts emitted event that Alice called PSP22 control.
Maybe Pierre to answer one question now, because I think you just answered it by example. So how many signatures will be necessary for XVM transactions?
Just 1.
Yeah, so you just saw it was just 1 call.
Yeah, just
that's the beauty of XVM.
Yeah. So right now, let's check that Alice holds 0 token. So Alice holds 0. And let's check that Bob holds 100. And Bob holds 100. Okay, guys.
So maybe just to repeat what we saw. So we have a contract on EVM, and we have Alice and Bob living on WASM, and they were able to transfer tokens back and forth, basically from WASM environment.
Yes, and I did not use the EVM call at all. So I think...
Yeah, so we have one more question.
Yes.
Question is there anyone here working on Ask implementation of XVM SDK?
Right now, no. There is no Ask implementation.
So whoever asked this, if you are interested to contribute, please contact the Astar team. So we'll try to engage you.
Yes, and as a rule for Ask, we see many of people you want Ask. So guys, more we have you asking, more we will do it. But it's a really, I would say, innovative right now EDSL targeting pallet contracts, and I don't think there's even one implementation of chain extension. So if you guys want to be the first, go ahead.
Pierre, maybe I can ask questions. So can you explain what would be the third VM in this scenario? What do you see as the next VM? If we want to edit, what would be the next virtual machine to use?
For example, we can use you can basically use any VM, but we can, for example, have a VM of WASM VM implemented. So you can basically deploy all the contract from WASM to Astar. We can have a near VM. Basically, everything that use WASM can be added, and basically everything that don't use WASM can be added, but then you will need to implement it in Rust substrate, so it's way more harder. But there's no limitation on it. It will depend on the community, what the community is asking.
Pierre, maybe you can explain a bit what is ask.
So ask, it's so you have Inc. Inc is Rust. So if you are not a Rust developer, it might be hard to learn Rust just to do smart contract. And smart contract is, custom business logic that should be used by anyone wanting to deploy a decentralized application. So we should not restrict our network to only one implementation of a language targeting our palette contracts. And the beauty of WASM is that all modern language can compile to WASM. So that's why we have ask, which is in assembly script, which is like TypeScript. So if you really know JavaScript, TypeScript, it will be more easier for you to write WASM smart contract for Astar than if you need to learn Rust. So basically, ask is Inc in assembly script.
Okay, I think we are coming to an end. Thanks everyone for joining. So here are some links if you want to contact us. You will find also this and other tech talks on YouTube later.
Yes, thanks guys for attending and thanks for your questions.
Yeah. Okay. Thank you.